Alright, ladies, here is your homework from last night from 10-3. Here are the even answers for you to check. I'll go over a couple problems again, and then we'll get started on notes. So I'll give you about a minute to check these. Alright, so I'm going to go over 20 and 35. 20, I hope, didn't give you too much problem, but we'll talk about it. Is a snowboarding rail shown as an arc of a circle, and BD is part of the diameter. If ABC is 32% of a complete circle, what is the measurement of AB? So, we had this semicircle snowboarding ramp. Let me draw that a little better. I don't know what that was. Okay, this was A, B, D, C. Okay, ABC, the whole thing, is 32% of the circle. So, I want to figure out this length then. Well, that's half of 32%. So, AB is 16% of the circle. So what I'm going to do here is try to figure out what the measurement of AB is. If you notice, it's just asking me for the arc measurement, which is the degrees, right? So if I can figure out what the degree is, then I'll be able to figure out the arc measurement. Now, a degree pretends if I drew this circle and it continued on, and so whatever that degree is. So if that's C in the center, okay? So angle A, actually call it E because we already have C, AEB, right? Well, if the arc measurement is 16% of the circle, then the degree measurement is as well. Well, what is 16% of 360? You just set up a ratio. Cross multiply. You get 100x equals 5760. So therefore x is 57.6, which is just the degree measurement. So 57.6 degrees. It wasn't asking me for the length, just the measurement. So, and I'm also going to do 35. Let's switch over to a new page. So in 35 we had that wonderful diagram. I'm going to do my best to sketch it without it getting too confusing. I'll do different colors. And And then we have this connection here. Had P. We had Q. There was a line. And these lines. Draw. This was 9. This was 11. And it said the chord between the chord AB, which this was A, this was B, is perpendicular to the segment connecting the centers. So it doesn't look it in my picture, but that's perpendicular. Okay. If AB is 10, what is the length of PQ? Well, let's look here. All right. So it's kind of hard to see. If I took P and I took it away from that mess, AB is right here. And we said it's perpendicular, right? Same with circle Q. If I took it out of that mess, AB, it's the same AB. Okay? With this being 11 and this being 9. I just took it apart so it looks less confusing. Okay, it's the same AB though. And AB is 10. Well, we have a perpendicular from the radius, from the center, which means these are cut in half. So this is 5 and this is 5 if AB was 10. Okay? Or we can look at it back up here and say, here's our 5, here's our 5. I want to know the distance from P to Q. So basically, I need to find this distance, we'll call it X, and this distance, oh, not X, we'll call it Y. So I just need to do 2 Pythagorean theorems, and I will have my answers. So I'll do this triangle here, P, A, and I'll say C for where it meets. This was 11, this was 5, here's X. A, C, and Q. This was 9, this was 5. So when I do my Pythagorean theorem, it's 11 squared plus 5 squared equals, no, 11 squared equals 5 squared plus x squared. I solve, and I get 96 is equal to x squared, so square root of 96 is equal to x. Okay? Well, I'm going to leave that for right now. And this was our y, so 5 squared plus y squared equals 9 squared. So that gives me y is equal to square root of 56. Okay, let's see if these can be simplified because it's x plus y, right? Square root of 96 plus square root of 56. Let's look at factors of 96. We have 2 and 48, 2 and 24, 6 and 4, 2s, 3 and 2. So I've got a pair of 2s, a pair of 2s. So that's 4 square root of 6. When I look at 56, I have 8 times 7, 2 times 2 times 2. So plus 2 square root of 17. So you can leave it like that, or since it doesn't specify, you can round, and that distance is about 18.04. Actually, hold on, it's not 18.4, it's not 17 in the square root, that's 4. My apologies. When you type that in, 17.28, 17.3, which is what the book said. So that's kind of that problem all worked out. I hope that helps. Again, if you have questions, go see Mr. Silberman or any of the other teachers. They'd be glad to help. So we're going to move on to the warm-up. I'll give you about a minute to do this warm-up, and we'll get started. Okay, so the radius of R is 35. Arc LM is 80. So if I look at this picture, first of all, perpendicular is a bisector. So if LM is 80, then each little piece is 40. Okay, same here, because these are all congruent to each other. Well, actually, I made that up. I don't know that just yet. LM is 45, so then that means that these pieces are 22.5. And LM is equal to NO. Okay, so now I do know that all of these pieces are equal to each other. Find arc measure of NO. Well, again, if the chords are congruent, which we're told, then the arcs are congruent. So if LM is 80, then NO is also 80. NQ. Well, this perpendicular means it's been bisected, so it's going to be half of NO. That's 40. Segment NO, well, we know is congruent to LM. LM is 45, so that's 45. NT, again, perpendicular means it's cut in half here. So NT is half of NO, 22.5. Now RT, not as straightforward. So RT is called X. Alright, I know that the radius is 35. So I'm going to draw in a radius right there. 35 tells me the radius right there. And I know NT is 22.5. So to find RT, Pythagorean theorem, 35 squared equals 22.5 squared plus x squared. Alright, when I do that, the rounded version is, let's see, the rounded version is 26.81. The exact version, though, let's look. when I bring everything over at 718.75 is equal to x squared. Well, that fraction is 2875 over 4 equals x squared. When I take the square root on top, that ends up simplifying to 5 square root of 115 over 2. Alright, so that's the exact version of it. You should know how to do that if I asked. Okay, so moving on. Inscribed angles. First of all, it's good to know inscribed, that's the same as on. So it's on the circle. So if we're looking at angle 1, it's inscribed because the vertex is on the circle. It's not outside of it, it's not inside of it, it's right on it. If you have an angle that's inscribed, if it's on, then that angle is half of the arc. So like it says here, angle 1 is half of AB, or if you look at it the other way, AB is twice of angle 1. So looking at x in this problem, if I want to find that angle, looking at the arc it creates, 86, it makes an 86 degree arc. That means angle x is half of 86, which is 43. Okay. Here I want to find arc yx. I know the inscribed angle that makes that arc is 52. So that's going to be twice 52, which is 104. Okay? Pretty simple. So here, if two inscribed angles either intercept the same arc, so if I'm looking here at angle DCA creates arc AD. But angle DBA also creates the same arc AD. If that happens, then these two angles are congruent. Okay? Or if they create congruent arcs. So if it's different arcs but they're congruent, then the angles are congruent. So here let's find R. Okay? Well, angle R. I don't know this arc because angle R makes this arc. But other information that I'm told is angle S, which angle S also creates the same arc. Therefore, those are congruent angles. So 12x minus 13 equals 9x plus 2. So I get 3x is equal to 15. So x is 5. So angle R, when I plug in 5, gives me 47 degrees. Two congruent arcs, or the same arc, means congruent angles. Okay. If you have the inscribed angle and it makes a semicircle arc, or if it cuts off at the diameter, which is the same thing, FH is the diameter, then this inscribed angle is 90 degrees. Okay? Again, well, not again, but if you don't remember that, and you just remember your half rule, remember it's a semicircle. So this is 180. The angle is half, so the angle is 90, a right angle. Okay? So if it makes a semicircle or it cuts at the diameter, then it's a right angle. So here, angle B. Alright? I see that AB is a diameter. So I know angle C is 90. But angle B, it doesn't create the same arc that A does, so I can't set them equal. Because angle B makes this arc, whereas, give me the pen, come on. Well, it won't let me change color pens right now. Whereas angle A makes this arc, so I can't set them equal to. But they are parts of a triangle, so I can set all those angles, those three angles in that triangle, equal to 180. Angle A, angle B, and angle C, which is 90, equal to 180. So when I combine these like terms, 9x plus 4 minus 4 plus 90, that's just 90, equals 180. 9x equals 90, so x is 10. Therefore, angle B is 8 times 10 minus 4, 76 degrees. Okay. So now, if I have a quadrilateral inscribed in the circle, then the opposite angles are supplementary. Which, again, remember, that means they equal 180. So I'm not going to write it like that because that makes them look congruent. But angle M and angle K equal 180. The sum of angle L and angle N equal 180. So now I want to find S and T. Well, looking at this picture, I know U is 14x and T is 8x plus 4. But I also see that B is a right angle. Well, if opposite angles are supplementary, then that means that this is 90, so that this is 90, that's a right angle too. So angle S is 90. Okay? To figure out angle T, well, U plus T equals 180, so 14x plus 8x plus 4 equals 180. So I get 22x is equal to 176. X is 8. When I plug in to find T, 8 times 8 plus 4, measurement of angle T, 68 degrees. Okay. So now we got kind of a lot going on. Make sure you're labeling your diagram. AC is a diameter. Okay, good to know. CD, arc CD, is 68. Okay, arc BE, arc BE is 96. Okay, find angle ABC, angle BDE, angle CED, and arc measure of AD. Okay, well, let's look. Angle ABC. Well, let's just start there and let's look. Angle ABC intersects my diameter. You see that? It intersects my diameter. that intersects the circle here and here. So what does that mean? Well, that means that angle ABC is a right angle, is 90 degrees. Okay. Let's look at angle BDE. Okay. Angle BDE. Well, that intersects my 96-degree arc. So BDE has to equal half of 96, which that gives me 48 degrees. Alright, so I found this one, I found this one. CED. Let's look at CED. Okay. CED intersects my arc at 68 degrees. So that means the measurement of angle CED is 1/2 of 68, which is 34. And now I want to find arc AD. Okay? Well, if I look, I'm going to erase some of this that I've done to make it a little bit clearer. Okay? AD is this blue one. Okay? Well, I don't have an angle that has created AD, so I can't look at that. But what I do notice is that I know CD, okay, and I can see that CD plus 80 has to equal 180 because it's marked off by my diameter. So the measurement of AD is going to be 180 minus CD, which is 68, which that's 1/12. So that's that problem there, using inscribed angles, and for AD, realizing that it's part of a semicircle arc. Alright, so in this circle X, I know angle 4 is 7y plus 3. Angle 5 is also 7y plus 3. Angle 1 is 5y. Find the measurements of 1, 2, 4, and 5. Well, let's look. It's the same variable y, so if I can figure out y, I'll be able to figure out most of these. Alright? I look and I first notice that 6 and 3 cut off my diameter, which means they're 90 degrees right here. Okay? So I can figure out y using the top triangle by saying 90 plus 7y plus 3 plus 7y plus 3 equals 180. Okay? And that'll be fine. What's something else to notice though is that 7y plus 3 and 7y plus 3, that means that 4 is congruent to 5. And if this is 90, then that leaves 4 and 5 have to be 45 degrees. So there's two answers right there. So those have to be 45. because it's an isosceles right triangle. Because if these are congruent, then that means these are congruent, right? It doesn't mean anything about the other triangle though, so don't assume that. But now I can figure out what y is if I go this route by saying 7y plus 3 equals 45. So 7y is equal to 42, y is 6. You would have been totally fine to say, like I said, 90 plus 7y plus 3 plus 7y plus 3 equals 180. You'll still get y to be 6. And then you can go and plug in and find that 4 and 5 are both 45. Okay, if y is 6, now I've got to figure out measurement of angle 1. Well, measurement of angle 1 is 5y. So 5 times 6, right? 30. Measurement of angle 2 then. You just take, you can realize it's a 30, 60, 90 triangle. Or do 180 equals 90 plus 30 plus, call it x, for angle 2. And you'll get 60. Okay. Last slide and then we're done. We have an inscribed quadrilateral, finding the measurement of Q, R, and then this arc TQR. So remember Q, okay? Inscribed quadrilateral means opposite angles are supplementary. So that leaves Q. Q plus 100 equals 180. So Q's got to be 80 degrees. 180 minus 100. Again, R and T are supplementary. 180 minus 95. Well, that's 85. And now TQR. So TQR is T, then Q, then R, right there. Okay? I can look and see that what creates that arc is angle S. Remember, inscribed angle is twice the arc. Or the arc is twice the angle, excuse me. I always say that wrong. The arc is twice the angle. So the arc is 200 degrees. Okay? Again, lots of rules. Make note cards. Make a Quizlet. Do whatever it takes. This lesson is not on your quiz tomorrow, so don't worry about that. But you got a few minutes. You can start your homework quietly and be good to go.